This is the first video that relates to chapter 8 difference equations. Some really simple questions to start. We're just asked whether these sequences are linear, quadratic, cubic or none. So let's write A out. 9, 14, 21, 30 and 41. Let's write down our differences. Let's see where we go. The first difference is 5, then we have 7, then 9, then 11. And we can see here that the second difference is the same, 2. We also know that 2a is equal to the second difference in a quadratic equation. So a is quadratic. If we look at b, 19, 22, 25, you can see straight away the differences are 3, 28, 31. Next one will be 34. Same difference all the way across of 3. So b is linear. C, we have 5, 7, 12, 9, 31, 50, 19, 31, 50 even. So let's have a look at these differences. We have a 2, a 5, a 7. Just double check, 2, 5, 7, and 19 up to 31 will be 12, and 31 to 50 will be 19. Then we have 3, it's up 2, up 5, up 7. So no consistency here. 3 to 2 is down 1. 2 to 5 is up 3. 5 to 7 is up 2. First, second, third difference, not the same. So it's none of these. For C, so D must be cubic. Let's double check that the third difference is the same. 3, 22, 59, 120 and 211. So my differences are 19, 37, 120 minus 59 is 61, and 211 minus 120 is 80 and 11, which is 91. And our second difference, 19 up to 37, 18, 37 to 61 is 24, and 61 to 91 is 30. We can see here the third difference is the same, 6 and 6. So C, D is cubic. So that's question 1. Practice these, your first, second, third differences, and then move on to question 2. Question 2, we have in each case identify linear, quadratic, cubic or none, and write down the next term. And we're given this first time you're going to see this Fibonacci kind of variation. We add 3 terms together. 1, 1 and 2 you can see is equal to 4. If I take the 1, the 2 and the 4, they add up to 7 and so on. So we'll come to the Fibonacci now in a second. So the first one we can see here, we can see the difference between 14 and 19, 19 and 24, 24 and 29 is all 5, so this one is linear. I'll just do L for linear. 39 is going to be the next term. 6, 12, I'll write this one out. 6, 12, 20, 30, 42. You might see going forward, T2 minus T1 is equal to the difference, or T3 minus T2, or Tn plus 1 minus Tn. Another way of seeing this, just to introduce it as we go forward. So the differences, I'll do them down here. 6 to 12 is 6, 12 to 20 is 8, 20 to 30 is 10, and 30 to 42 will be 12. And then the second difference is the same here, 2. Second difference is the same, it has to be quadratic. And if we think about the next term, the next along here, 6, 8, 10, 12, this will be 14. So 42 and 14 will be 56. So we put that in here, 56. The next one, 0, 7, 26. I'll write it out again. 0, 7, 26, 63. 1, 2, 4. You just set your calculator up here to do all these. 7, 19, 26 to 63 will be 37, and 63 to 124 will be 61. Second difference are not the same. We have 12, 18 and 24, and we can see now there's definitely some third difference the same here. 6 and 6, 6 and 6, so this one is cubic. C for cubic. And then the next term, we work our way back up. We have a 6 here, so 12, 18, 24, this will be 30 to keep our 6 difference. And if you see going down this way, 37 and 24, 61. 61 and 30 will be 91. Would have to be this difference here. And we'd have to add 124 and 91 to get 215. Let me just double check. 215. 215 is correct. Then we have 3, 10, 20, 3, 10, 21, 36, 55, 7, 14, no, 7 not 14, 7, 11, then we have 15, and then we have 19. Second difference the same here is 4. So this one's quadratic. If we work our way back up to keep the 4 difference down the bottom, this would have to be 23. 55 and 23 would be 78 for this one. Then we have 18, 16. We have a descending sequence here. It's linear. You see all the differences are -2 here. So we have a linear sequence. Don't need to write it out. And the next term will be 8 going backwards 2. And then the Fibonacci, which I haven't seen either until making this video, or well, reading this chapter. If we add these 3 numbers together, 20 and 40 is 60, 60 and 80 is 140, which leaves 4, 4 and 1, 149. T for Fibonacci.